I received a comment after I posted my last video about the power consumption of this tandem set. And that comment was the discrepancy could be due to the power factor. So I pulled out the Suncor PR57 owner's manual, and they mentioned power factor as well. The way this device measures power consumption, or wattage, is basically by multiplying volts times amps. Well, power factor comes into play when you don't have a purely resistive load. Power factor relates to the voltage and current being out of phase. Now, the owner's manual, they say that, the power factor, the difference is so minor during normal service work, you can ignore it. Maybe not with this. Now, when I've measured the current draw with the fusible resistor pulled out, so just the filaments, which are a pure resistive load, it measures exactly 0.6 amps. But this uses a voltage doubler, which would be a capacitive load, I believe, and it might have enough of a phase shift that it accounts for the difference. Now, potentially, I might be able to do a little measurement and see how much current does the B plus draw. So now the filaments are 0.6 amps, and if I can figure out what current's being drawn in the B plus, so for example, I could measure the voltage drop across the fusible resistor. However, I think that might be a complex waveform at that point. Although my Fluke is a true RMS meter, so it should be able to handle that. So I'm going to give that a shot. I can measure the resistance of that thing right there, measure the voltage drop across it, and then I should be able to calculate the current. So the 600 milliamps are drawn by the tube filaments, plus that current, should give me the true current draw of this set. Okay, I measured exactly 4.5 volts, and this measured 5.8 ohms, 0.77, and if I add 0.6 for the tube filaments, I get about 1.38 amps, which is a little higher than what I was measuring. I was measuring about 1.25, 1.2 amps. Sam says 1.65. I calculated 1.37. So I think that's enough experimenting with this. I'll just move on. But I am curious as to what device did Sam's use when they measured the current draw on this. I believe there's a way you can do it by actually using temperature. So you have it, instead of, typically an ammeter measures the voltage drop across the resistor like I just did, but another way to do it is to have a thermistor and measure the temperature, and the temperature will be dependent on the current flow, and it will handle a complex waveform. I think that's how some watt meters work, but anyways, enough with that. Now what I want to move on to is restoring this head assembly. I've been holding off on doing anything with this because I wanted this as a reference while I was experimenting with the current draw, but I think I'm done with that. So I want to pop this thing apart because it has not been recapped. And the picture tube is also very, very weak. I want to test it again. It's been a while. I want to see how weak is it really, because I know that it's got a terrible picture on it right now. I'll want to do a recap and then leave this picture tube in there and see if it improves. If it improves enough, I'll leave this picture tube in there and I'll just keep using it until it dies. But if it still looks terrible after a recap, then I do have new old stock silver armor picture tube I could put in here, but it's going to require some slight modifications. I was studying the data sheet for it. It's a 21AFP4, I think, or FAP4, I don't know. But anyways, it's not the recommended replacement. And I checked the pinouts and the voltages, and I'll have to do a little tinkering, a little bit of rewiring on the socket, and I need the G2 voltage needs to be raised a bit. So That's why I want to use this one as long as I can. Okay, in order to service this, I have to take the front and back covers off. I mentioned in an earlier video that the way that they tell you to disassemble it in the service instructions is to undo this spring that's hidden down in here, which is really difficult to do. So I always dread taking these apart, and then somebody mentioned on Video Karma a tip: forget about the spring, leave the spring in there. Just pull up on this band hard. You can usually work up enough slack that you can pop it off. So I was able to do that on the other one and my holiday set with no trouble. So let's see if I can do it on this one. So inside of this brass colored plastic, there's actually a piece of spring steel that runs around, or I think, or something like that. Ooh, that is nasty. Underneath this, actually, so there's a bit of a sliver of metal in here to give it some integrity, but underneath that is a thicker piece of spring steel that really holds this together, and this one is all rusted out. So another job for Evapor-Rust, I think. Okay. Once you get one of these little ear things, once you get over one of them, it becomes a much easier task. A little rough on the fingers, for sure. This one's being stubborn. There we go. The reason I was having so much trouble is that I was actually grabbing the piece of spring steel underneath the plastic, not just the plastic. There it is. So, rust. I haven't seen one of these rusty before. Here's a look at that rust. Some grime too. Oh, no big deal though, so I'll just get some rust remover working on that. No big deal. And I'll clean all the plastic off. So the original finish on this is kind of like blackened. I do have a gun bluing kit. Maybe I can try that on this once I get the rust off. Anyways, so down here there's a bit of decorative trim, 2 screws. If I take that off, I can unhook the spring. Get this out of there, and then it reveals a bolt on either side. You undo those, it takes this piece of spring steel off, and the whole front just comes right off. I got the cover off without any incident, so now I can finally see what's going on the inside. There's the original Philco picture tube, 21E8P4. I noticed the masking tape came loose that would have been holding this down more securely against the conductive coating. I'll replace that. The only thing I want to do is I had this powered up just a while ago, so I want to make sure I discharge it. Ooh, definitely glad I did that. Now there is an effect, I believe it's called dielectric absorption, which is where a capacitor can actually build a charge back up after you discharge it. I think it's something to do with the dielectric material can actually, I think the electric field across it actually causes it to store some energy. It takes a little bit of time to completely release. It's pretty much discharged. Something else you can do is just keep it grounded. So, yeah. Alright, so original parts in there, so that's what I really wanted to get at. 1, 2 paper caps, and 1 electrolytic. And of course I'll check the resistors. I've already checked the tube, it's okay. And I want to retest the picture tube. when I got this, I recall the emissions were like 3 ticks from 0, so well into the bad range. Okay, let's give this a try. Now, remember, low voltage, 2.34 volts. Turn your tester down, because you probably have it set for 6.3. Just blow the filament out. Very likely. So 2.34. Oh, let's see, that tick for 2.5. I'll just set it for a little. Let's back up a range here. Yeah. Alright, so I'm just glowing. Oops. Ooh. It's kind of erratic there.
I think we've had you on as a regular since then. Pretty much around. Yeah, certainly. I remember right around the elections in 2000, end of 2006, 2007. I know we really started talking. So yeah, it's been
cutoff range 36. Yeah, that's alright. Alright, so cutoff is actually good. Or I can get it, into the right area. Oh, emissions are bad, but they're actually not as bad as I had remembered. And I have tried rejuvenating this, in case you're curious. So I'm not going to try doing it again. I imagine the life test is just, appalling. I'm curious. I thought that the needle was more like down here than up there. I mean, obviously, I've had this hooked up to a set, so kind of what it looks like. I try just tweaking the filament up a little bit. Let's see if the emissions go up much.
Pretty close. Your colleague Ben Jarofsky writes a lot about Rob. It's safe to say he writes a lot about Rob. Nick, you're right. That is safe to say.
A bit more.
I think if Ben were here, he would be the first to admit that that's almost all that he writes.
So let's see where we're at now.
There is plenty there's always something going, and Ben's got a particular...
So probably if I got this up to about 3 volts, I would be just at the edge of green.
I love reading the stuff that Ben writes about him. He's hilarious. Absolutely. He's like on point. Yeah, so absolutely.
Gonna life test this horrible. I don't want to burn this out, so I'll turn it back down.
Everybody remembers the election. It seems like it just happened. I know. Isn't that crazy?
Alright, anyways, I will get to the recapping now. I finished recapping the CRT. Not a whole lot to it, really. When I checked the resistors, they were all off a bit, but this one in particular, 47K, measured 70K, so almost twice what it's supposed to. And here is the results. I also moved the focus jumper from one position to the other, which helped a lot. So it's actually looking really good now, with one condition: you've got to keep the brightness down. As is typical with CRTs that are wearing out, if you crank the brightness up, the bright areas, you lose definition, you lose focus. But if I keep it down a bit, not too bad. Now, so the only problem is you got to watch this in a dim room. So, what am I going to do? Well, right now I'm going to leave this one in the set. But I definitely will plan on replacing it. I've got one on hand, as I mentioned. And I think I've got one that will be arriving in a few days. Neither one of which is a perfect replacement. They're both going to require some tinkering. So I'm going to wait till the other one arrives and compare the two, both physically and electrically, and see which would work best. Ooh. Must have a problem with the socket. I just had to wiggle the cable a bit and the picture's back, although a little unstable, so I better clean the pins on that socket. So as I had mentioned, I do plan on replacing that picture tube, and another one should be arriving soon, and then I'll have a decision to make. Well, that time has come. In fact, I got 2 picture tubes, and there are actually some more on the way. Somebody found a little stash of picture tubes, and I picked up a few of them. Now, these are all rebuilds. Don't be deceived when it says all new, because all new except for the glass envelope, which prior to reuse has been inspected and tested to be standard as new envelope. So in other words, it's a rebuild, as is this. 14WP4, which I believe, in fact, I not only believe, I now know, can sub for a 14RP4, which is what is very commonly in the metal portable sets from the mid-late 50s, like the Bug-Eye sets. So that's why I picked this guy up. But I think this is electrostatic focus and aluminized. Well, and maybe the RP4 is too, I don't know. But anyways, that's why I grabbed that one. Now this is the one I think will work in the Predicta. I say think because I do not have exact data on it. All I do have is what's at the radiomuseum.org, which is a pinout and a filament voltage and current rating. And also somebody in one of the forums asked what will sub for a Predicta. And this one was listed as a candidate. However, it uses a different filament current. And since it's a series strung set, that's a little bit of an issue. But it uses less current. Less current is not that big a deal to handle. When it uses more current, that's when you got problems. Because they're all in series, and if you got one tube that needs more current, well, really the easiest way to handle that is to just add a separate power transformer, like a 6.3 volt filament transformer just for that picture tube. But in this case, this runs on 450 milliamps, whereas the rest of the tubes are 600. So what do? Well, instead of trying to cram too much current through it and burn it out, you just put a resistor across the filament leads. Just do a little math, figure out how to shunt 150 milliamps around the filament, and there you go. And if you really want to be paranoid, you can put some back-to-back Zener diodes across it to clamp the voltage so it won't go over. Because this is another low voltage screwball thing. So the original 21 EAP4, I think it is, used 2.34 volts at 600 milliamps. This is 2.68 volts at 450 milliamps. Otherwise, I think it's pretty much a drop-in replacement. The pinout looks to be the same. I think the voltage specs are close enough. And then there's the other issue, which is the physical dimensions. There are plenty of 21-inch, 110-degree deflection picture tubes out there, but most of them have longer necks. Like I actually picked up a 21 CEP4 a while ago and did a video on it. That would stick out like 3/4 or an inch from the back of the picture tube. I would have to leave the cover off or modify the cover. Well, now I won't. Now, there's also this guy. This one I do have the full data on, and this is 600 milliamps, but it's 6.3 volts AC, so higher voltage, not really a big deal. But different pinout and slightly different voltage ratings. But this is new old stock, not a rebuild. So, what I'm planning, and I've tested this one, I know this one's good, and it looks to be physically, the dimensions are the same as the original. This one I still have to check, haven't opened the box yet. Don't even know if it's good. But if it is, this I want to put in my best set. And from examining my various tandem head units, the plastic and all that, I think the best one is actually the one that's in storage with the cutoff cable. So that's where I plan on putting this one. Now, one of them already has a replacement picture tube, so of course I don't need to touch that. And then the third one is the one I'm working on right now, which is turned out to be kind of rusty and nasty inside. That's where I think this is going to go. So let's pop this open and see if it's any good. Oh, and notice this. Even though all the printing seems to indicate that this is right side up, notice the note on both of them. You'll see when I open this why they say that. Now, I've debated with some guys about how you should ship and store these. This way, so you can read the printing, in which case the face of the CRT is down, so the heavier part is down, or up. I think they should be stored upside down, so that the face is up. Why? Well, so if there's any junk that breaks loose from the electron gun, it won't fall on the face and rattle around and scratch it up, and the face of it won't get scratched up. There is bracing inside to keep it supported firmly, so the neck won't get crushed if you put it the other way around. And I know for a fact, earlier round black and white picture tubes, I've got a couple new old stock and original boxes, and they absolutely say this way up, and the face of the CRT, the heavy end, is up. I just noticed it does clearly say this side up, but then open this end, so that there's a paradox. So it probably is right that you are supposed to store it and ship it with this side up, but obviously you have to open it from this end because there's no way to get it in and out from the other end. All right. Alright, looks to be defect free. No scratches or anything. Hopefully it's not broken. Here's how it was supported inside the box. So it's going to handle plenty of weight. That's why I was suggesting that you could store it with the face up and there wouldn't be any problem. Alright, so what does the other side look like? Well, here we go. I've seen better jobs of rebuilding. It's a little crooked, which means the yoke, well, hopefully there's enough slop that won't really be an issue. And then of course, who's to say it's any good? I've heard there are potential problems with the rebuilds, with bits of contamination that can get inside there. There's a nice bit of glass that dribbled over the edge. I imagine these are a bit more of a challenge to rebuild than the ones, well, like that one over there. It's also a rebuild, I think. Not a whole lot to work with. Alright, so some paperwork here. 21 EVP4. And a warranty card. I better send that in within 10 days. 3-year warranty. There's a date. Channel Master, Island View, New York. Grade A. I'm curious to see what was under here. I wonder what this was originally. Because when you regun it, of course, you can put a different kind of gun in there. This might have been a different current rating. For all I know, this is an original Philco tube, and they put a different kind of gun in it. Now for the moment of truth, is it any good? Well, let's see. Double check all my settings here. I'll make sure I got this put all the way down to 1 just for safety's sake. And cut off down. Alright. Fill set. Start turning this up. Alright, now I gotta go up a range. Looking for 2.68, which I don't think I can get on this range, the 2 range. I'll probably have to go up a bit, but before then, should be able to see it glow. Yep. Not real bright, but it's glowing. So they have ranges on here, 1, 2, 3, 4, 5, 6, and each range roughly goes across that spans 1 to 2 range and go from about 1 to 2 volts. Or 2.5. But here's one thing I don't like about this tester. So I'm on the 3 range, I'm bottomed out. I get about 2.5 on the meter. If I go down a range and turn it all the way up, I barely get over 2. So if you wanted like 2.25, 2.4, you can't get it. There's a gap in between the ranges, in other words. Anyways. So 2.68, it's about on 3 with this down all the way. And it's not super bright. You never know with these. I've encountered other tubes where they put a different gun in them, like a 600 milliamp gun and a 450 milliamp CRT. But we'll see. We'll see how it tests. No shorts, fantastic. Yeah, fantastic cutoff. Very responsive. And emissions as we hoped. Above 12. Pushing the life test button. Doesn't move. Alright. Exactly how a new picture tube should test. Now, there's one thing I'm curious about this CRTs. So, the original 600 milliamp, let's just say 2.5 volts. This, about 2.5 volts and 450 milliamps. And then there's another replacement that's 6.3 volts at 600 milliamps. So how can they all have about the same emissions? In other words, the traditional CRT, 6.3 volts, 600 milliamps, that's about 3.5 watts. But something like this is about 1 watt. Did they really improve electron gun efficiency so much that you can use just 1/3 the wattage and have just as much life and produce just as sharp a picture? I hope so. Otherwise, this may not last so long. And if they could, why didn't they incorporate that into all picture tubes? In other words, why weren't they all low current or low filament voltage? I figure there's got to be some design trade-off. I don't know. Maybe some of you out there who know more about CRT technology can fill me in. Now, maybe this just was leading edge technology, and they did all gradually become lower and lower wattage, and it will last just fine. I certainly hope so. All right, so that's great. Now, something I don't want to do because it's just not much. Well, it's not much fun to replace a CRT in the best of circumstances. This is going to be a bit of a challenge. I have not done it before. I've been studying this and some diagrams, and I get the gist of what needs to be done. So, we've got this base here, and we've got straps running around the picture tube. We got one that goes around the perimeter with a bolt on this side. So obviously you loosen that up. And there's also a strap that goes around. Obviously it doesn't wrap around the whole thing, otherwise it would go across the face of the CRT, but it kind of hooks around the top and the bottom. And there are two here, so I assume you need to loosen up those two. Now this assembly is attached to this strap, although you can take it off if you want. And of course I got to take the base off the CRT, that's simple enough. And then there's the yoke assembly. There's a 1/4 inch nut down somewhere to the band. I assume I can loosen that up. This will loosen up. I can slide it off. I'll loosen up this, loosen up these two, and the whole picture tube should just flop over. I'll probably do is set this so it's face down on a towel, and then loosen these up and kind of pull this away from it. I don't want to just loosen it up like this and it would fall over. Yeah, I know it's really weak, but I suppose I'll hang on to it in case some rebuilding operations ever get going. I now have 3 of these very weak 21 EAP4s. Oh, if I ever run into somebody who has a totally dead picture tube, hey, it'll produce an image. It's something, anyways. Oh, alright, so that is the game plan. And I might as well get some practice because I'm going to have to do this on at least one other set. So far, so good. Just pulled out the high voltage cable after I had a discharge clip hooked up for hours. Popped the CRT socket off, loosened up this screw, and the whole yoke started to move. Which means I don't have to touch the one that's further down under the yoke. That guy. So this is super loose. Pull this tape off, so that's loose. So this is disconnected. So I don't think there's anything holding this in except these. So put this face down, towel, loosen those up, and then try to pull this whole back thing away, leaving the CRT here, swap out the new one, and put this right back on top of the new one. But before I take out the old picture tube, seems like a perfect opportunity to clean this up. So pop the bottom off the base, and you can see this one's in much better condition than the other one I previously examined. And this one's just in two halves. The other looks like it's in three sections and it's split in two places, but this looks like it's just two pieces down the center. Alright, so I'm going to clean up this cable, and then we'll see about doing that. Oh, and I just looped the cable over my camera tripod. I got shoved under some test equipment to keep this thing from putting too much strain. I slipped all the stuff onto the new picture tube without too much trouble. I'm starting to tighten things down, and I noticed that this band is kind of low down. It should be further up. Now there's a hook around the face, on the bottom, on the top, and those are firmly in place. So the only way you can get this band up, I think, is to tighten these down a little bit. So I'm going to give that a try. That should have the effect of moving this whole base up. Pull these up a little bit, because right now I think they should be more like up here rather than down where they're at. But I don't know if there's a whole lot of leeway there, because these are kind of, well, they're spot welded on, so well, maybe that is as good as it's gonna get. I just need to pull up on this a little bit while I'm tightening that nut down. Something like that. No, I'll figure it out. Alright, I guess that's in there. Good enough. Certainly good enough to try firing up. One thing I'm not 100% sure about, and I don't think I will be until I try putting the cover on, is it oriented properly vertically? Because there's a little bit of leeway. You can swing it like that a little bit. So we'll see. Also, I had to crank down these bands a bit more than I expected. Now, there's always some variation. If you look at data on CRTs, when they specify the dimensions, it's usually plus minus like 1/8 of an inch or 1/16 of an inch. So this may just be slightly smaller than the one that was in here. Now, the reason you need these bands tight, not only just to kind of hold this thing, because most of it's really done on these outside bands, it's that this strap is what holds this in place, and if this strap is loose, this thing just really flops around. Even as it is, it's not incredibly secure. Also, it seems to me it's a little close to that yoke, but I'll check reference photos and see. Just don't want anything arcing. I'm not sure about this wire. How it should be dressed exactly. So now I have to be careful not to just pop this on and plug this into a set, because I will burn out the CRT very likely, or at least it's going to glow really bright, because remember, 450 milliamp CRT 600 milliamp set. So how do you deal with that? Well, time for a little math. I compared this to my reference photos, and actually, yeah, everything is pretty much situated where it should be with the leads and the spacing and everything. Now, one issue has presented itself, though. Trying to plug this into the CRT doesn't want to go in. Why? Because when they put on the new gun, it's not keyed the same way the original was, or at least not keyed the same way the 21 EAP4 that used to be in here was, which had the key straight down. Now the key's off to the left. Not a big deal. I just have to kind of twist these very brittle wires around a little so I can get it on like so. Alright, now, before I can do that though, just set some math. So, original CRT was rated 600, this one's rated at 400, so imagine this is the CRT filament inside here. But the set runs on 600, and this is in a string. Now, if I didn't do anything, it actually probably wouldn't burn out the CRT. The circuit wouldn't force 600 to flow through here. This would actually restrict it such that 600 didn't flow through the other tubes. It'd be less than 600. It'd probably balance out so there'd be a bit over 450, but certainly less than 600 going through the whole circuit. Well, don't want that. So, what you simply do is do a shunt, just like you would if, like, you're making your own ammeter, and say you got a 1 milliamp meter and you want to make a 1 amp meter, you put a shunt. You put a low-valued resistor across it, and so most of the current flows through that. In this case, we just want a little bit, so we want 150 milliamps flowing through here. We got 450 going through there. We get 600 total. Well, it's 2.68 volt filament. Divide that by 0.15 amps, and you get 17 and change. Let's call it 18 ohms. So I'll dig one of those up. Now, I got to trace out the wiring to figure out where exactly that goes, and I'm a little confused because the filament pins should be the pins on either side of the keyway. Well, the way these wires go into the socket, I'm not quite sure what that is, because we got one wire coming in here, which is right in between those two pins. I'm going to rivet over here, and then nothing over here, so I guess I'll just have to use my ohm meter to trace out which wire is what. Well, actually, no, it's a lot easier than that, because the current's flowing through this tube. So I just found the filament leads on this tube. It's probably these two wires. That's a safe bet. So, that might actually work to my benefit. So these are the two leads for the CRT socket. I can tack my resistor in. Okay, so one's going over here. Yeah, that's it. It's got to be one of the wires. Tacks on here. This wire's not actually going to anything down in here. It's just threads around behind. So filament comes in here, goes to this wire, goes into the CRT, comes back here, and goes into this tube. And this is probably the return feed of the filament juice. So what I gotta do is tack between here and here that 18 ohm resistor. Then I can fire this puppy up. I double checked my assumptions about that wire, and it turns out that I was correct. So that's where I tacked in my 18 ohm resistor. And as far as the wattage rating, well, wattage is I squared R, so 0.15 amps squared times 18 equals 0.4. So I put in a 1 watt resistor. In other words, more than twice the dissipated heat. That should be all right. So now to try it out, I popped out the fusible resistor, so we're just going to get current flow. I want to check that we get about 600 milliamps flowing through this. So that's on, and let's see. something's not right. The AC cord plugged in, the CRT plugged in. All the tubes are in place. Well, better double check things. Hopefully it's something minor. Oh yeah, it's something minor, alright. Forgot the little detail that there's an AC interlock on the back of the set. So I'll just temporarily pop this cover on. The little interlock plug there. Alright. Now then, let's try that again. Alright. And it's settling down to right on 0.6 amps. Actually, that'll be just a shade under. See the CRT glowing down in there, as well as the 3CB6. Okay, everything seems alright. Now I'm going to double check, grab a voltmeter and check the AC volts across that resistor and make sure it's 2.68 or thereabouts. I'd say that's close enough, and I probably have this line voltage on the one low side. Well, just about 117. Turn it up just a little bit. Now we're a little high. What I'm probably going to end up doing, especially since this set probably will end up being run on something like 125 volts, is I'm going to increase the resistance of the filament dropper inside the set. But for now, I'm going to just turn this down a little. There's the tolerance on these tube filaments, I think it's plus minus 5%. So maybe it's 10%. So you don't want to vary too much. Let's say it's 10% because the math's easier. So if it's supposed to be 2.68, you go 0.268 above and below. So the max you'd want to put in is like 0.9 something thereabouts. So or say it's plus minus 5%, you probably go up to about 2.8 or 2.75 or so. So you do have some leeway, but you will shorten the life if you put too much voltage across it, which of course translates into too much current going through it. Alright, now finally a real power-up test. If it seems like I'm being paranoid, that's because I am, because these CRTs are very scarce. And the last thing in the world I want to do is burn this thing out. Should come up fairly quick because I just had the filaments powered up. Well, that's a good sign. Oh, don't have my box turned on. Okay, well, it's off center a bit, and probably have to adjust the width and the height. Not too surprising. The squiggly line is very annoying, but all that can be dealt with. Oh yeah, it's a much better picture. And I might want to check the focus setting. Anyways, yeah, I got the brightness up all the way now. The focus is staying locked in. I can get the contrast all the way, brightness all the way up. Alright, it's time for night gallery. I think this set would really benefit from an alignment. So right here is about the best picture, but the best sound is more like over here. That's an especially good night gallery. It's where a vampire wants to have an elaborate funeral because he missed out on one when the first time around he died or something like that. So it's off. So I just realized they had a test pattern up on the screen. Hey, put that back up there. So that brief moment the test pattern was up, I could see that things are off center to the right a bit. And I can pretty much tell that already because it's cut off on the left. So the way the centering works apparently is these things. I guess you turn them. I don't know if I should use needle nose pliers and grab that little tab there and try to rotate them, or was there a special tool that went around? Well, they do turn. So I guess I'll just play with that a little bit and see what effect it has. The other thing I wanted to try doing was switch this jumper. See focus. Alright, try another test.
We like to pass that along to people that come to us for comfort. Very nice. Extremely poetic. But now to the point.
I'm not sure.
I should like to engage.
I think it was better the other way.
I see. That would be the Eternal Rest Room. It's purple. That's a royal covering. Splendid. I should also.
That's good. So that wavy bright line actually goes away when you adjust the fine tuning. That's cool. So I can get good sound at this point. I'll be all set.
I feel that Silkline will be able to meet your every need in this moment of your grievous sorrow. Because naturally, the things that you are requiring, they will involve just a wee bit more expenditure. Please. The cost is of no importance to me. I want only...
Now for the fun part. Trying to get this picture squared away as best as I can. Since my VA62 is acting up a bit, I'm switching to the leader, which unfortunately has kind of a weak RF output. I gotta troubleshoot that at some point. I don't think this is normal. I've had this issue since I got it, that the RF output is just weak on all my sets, but it's good enough to do what I'm trying to do here. So here's the convergence pattern. So that should be dead center. Things are off a little bit to the right, but overall the vertical and horizontal linearity, not bad. I could live with it as is. Tweak the centering a little bit. That shouldn't be a problem. It needs to be moved down a little bit and to the left a little bit. And I could tweak the linearity a little. Maybe it's a little bit, just because the squares are a little bit wider on the left than the right. There's a T-bar on the back. You can move in and out. Here's the result after tweaking the centering magnets and the linearity T-bar magnet, which I found out also can do a bit to correct pin cushioning errors. Not only can you take that T and deflect it in and out, but you can actually twist the T-bar part of it. Still a little screwy in the upper right corner. I'll show you in a moment with a test pattern, but I think it's about as good as it's going to get. I like bringing up these commercials because I think they're a pretty good test to see that you got things level and sharp and that it's not twisted or distorted. Other than that, obviously you can do it with a test pattern too, but if you can read that harsh contrast text and everything's readable, it's a pretty good sign. Now, as I was saying, this set also needs an alignment. So I think that will also help out a bit too. So I'm not going to focus much more on this picture tube until I finish making tweaks on the chassis itself. here's what I currently have with the test pattern. Ideally, you want every square to be exactly the same size and perfectly square. So a few issues I've got. One, it's a little bit off center, and two, the horizontal linearity is not so good. The squares are wider on the left than on the right, and a little bit of curvature on the right hand side. So what can you do about that? Well, they give you a simple potentiometer control on the set to adjust the vertical linearity. So adjusting that now. So now I've squished the top, now I'm stretching out the top. And there's also a height control, and the two interact to some extent, so I need to go back and forth, but straightforward. Now, as far as the horizontal linearity, there is no direct control to adjust that. Older sets from the 40s, they would typically have a coil, something like this, across a couple windings on the flyback to let you sort of tune the flyback. Well, as you get into the late 50s, into the 60s, most sets dispensed with the horizontal linearity control. Whether it was to save money or because they thought the sets were designed well enough it wasn't necessary, or they thought the end consumer would notice the difference, I don't know, but for whatever reason, they don't have a control like that. What they do have is a magnet mounted on the back of the set. And I've seen others that have several magnets that are not just for linearity, but also to adjust or correct for pin cushioning defects. Just kind of like this curvature here on the right hand side. I guess when you have a perfectly round picture tube, you don't end up really with pin cushioning effects. It's when you get into these rectangular CRTs that becomes more of an issue. Well, anyways. So there's this T-bar back here. Well, they don't give you any instructions in the service info on what to do with that exactly, but from my own experimentation and reading up others online, it seems you push it in or pull it out. It's mounted on a metal bar that's got some, that's malleable. You can bend it. So if I push it in, it starts stretching out the right-hand side. Like that. However, it starts bending these lines in too, so it's not exactly an ideal situation. Likewise, if I pull it out, it's crushing the right-hand side. So I do something kind of extreme like that. Kind of gets it better, but now I'm kind of curving even more on this side. So I could just leave it like that and live with it. Oh, there are also two magnets in the back for centering things, so right now it's a little too over to the right too far. I can move it back to the left. Well, there are actually some other things you can do. For one, there's a width control on the set. And right now I've actually got the width a little bit wider than it should be. I'll show you why. Shift it back. So now if I bring that back out, you can see that the right-hand side, it's actually really crushed at the extreme edge of the screen. So I just increased the width so that it pushes that right off to the side. Well, one thing I haven't checked yet is there's a resistor, a power resistor, in with this width control, and I got to double check that value. That might be off a little. Other things you can check is the damper tube and the horizontal output tube, because those affect the driving and then the flyback effect. Another thing you can do is you can actually tinker with the flyback, like adding in a linearity coil or a capacitor. Like I know it's a common old trick to increase the width is to throw a capacitor across a couple of windings on the flyback. Now that depends on your type of flyback and the kind of taps they have in the secondary or primary and what you can or can't do. Then you can start tinkering a little bit too with other circuit parameters, resistors, the biasing on the horizontal output tube, tinker with the drive level a little bit. Or you just, call it good enough. Because I was reading about these Predictas, and apparently it's a rare 21-inch Predicta that doesn't have some geometry defects. So I'm going to check a few basic things. I'll swap out the damper tube, horizontal output tube, and double check that width control. Otherwise, I'll play around with this a little bit more, then I'm just going to call it done. I stopped by the hardware store and picked up some friction tape, so I'm going to pop that yoke back off and add some of this just like the original had. And I also want to recoat this flyback. It turns out it's actually worse than I originally thought. When I just saw it from the top, so I just saw some fine cracks that the coating was alright, but with the cover completely removed, I can see now that chunks of it are broken off and it's oozing a bit. Because I've noticed that this flyback can ring sometimes, and I occasionally catch a little whiff of ozone, so I want to clean all this stuff out and recoat it. I do just like I did before. I'll remove a few wires here, unmount it, chip away at the old coating, and cover it with RTV133. That turned out fairly well, I think. I was able to pick off pretty much all the original coating and then smeared on the RTV133. It's been a few hours, still a little tacky. I'll let that cure overnight and then mount it back in the chassis. And then I will attempt my first Predicta alignment. I've briefly looked at it. It looks pretty straightforward. It's a modernish 44 megahertz. So I'll be able to use the B&K 415, I think. It's amazing how long this tube has lasted me of this RTV133. I cut the tip open on this over a year ago now, I'm pretty sure. It's when I started my holiday Predicta restoration, I think, and I've only used maybe that much. So I still have at least 2/3 of it left. And I've just been wrapping electrical tape over the tip. Occasionally there's a little bit of crust I got to pick away, but otherwise just run underneath the crust. It's still just as fresh as the first day I opened this. So it may have been a little expensive. I think it was 60 or 70 bucks. But I've already done 10 flybacks or so. I think I'll be able to do at least another 20. So it'll come down to just a couple bucks a flyback, I think. So not that bad if I got a whole lot of flybacks to recoat. Here's a look at the original again, and I just noticed that they had some of that fabric tape around the neck too. It's probably to keep the yoke from rotating. I noticed on the new one it's not too difficult, even though I tighten the clamp down. With a bit of force you can rotate it. This friction tape probably helps a little bit, so I think I might need to run out and see if I can pick some up. Try a handy thing to keep on hand. Now what am I going to do with this? Well, like I said, I'll hang on to it, but I mean physically where am I going to put it? Well, I'm going to put it in this box, which I think is what most people did. So you got to be careful when you see these supposedly new old stock picture tubes showing up on eBay, because this is what would happen back in the day. Some people get a new picture tube installed. The serviceman would take the old one, put it in the box, and people would stick it in the closet, and then 50, 60 years later, somebody's at an estate sale, they see it, hey, and they got a picture tube, they put it on eBay and try to get top dollar. So always be careful when you see the box, like say it's an RCA Silverama. Check the actual picture tube that's in it. You see something like this, it says Philco, blah, blah, blah. You know, if they don't match and it looks like it's been used, you got tape on here, whatever, it's not a new old stock picture tube, it's the old used worn out one.